In this video, I thought we'd explore working with z-scores a little bit more by taking a look at a couple of applied problems. These are actually simplified versions of some process improvement greenbelt projects that had been worked on by past participants, and I've changed the names and the companies to protect the innocent or guilty, however you want to take a look at it. But in the problems that we'll be taking a look at, they come from the Lean Six Sigma data analysis program, and I'm looking at problem number 4 and 6, which is a supply chain problem. And then number 7 is more of a service industry transactional service problem. The learning objectives for this particular module then include working with z-scores and the z-score formula, using z-score tables. I'm going to be using a simple z-score table in the calculations and analysis, and converting z-scores into percentages. Let's take a look at some of the details related to this problem. We've got lead time for a product that's being delivered from mainland China to a company's loading dock, and it's normally distributed. Much of the business data that you work with will be normally distributed. And the average is 45 days and the standard deviation is 10. We've got historical data and we've got central tendency and variation determinant. So I'm just going to draw that out as a picture. Okay, so your boss just realized that they need to get the next shipment to arrive in 30 days or less. So 45 days has worked well with this supplier relationship over the years, but the backstory behind the real case was that they had just won an opportunity at winning a new client, a big box department store that was going to be using their final assembled products. Some of the subcomponents were coming from China to Acme Corp, and it was taking 45 days, to ship across the ocean and get through customs, and that was fine. But now, in order to satisfy the needs of this new client that was that they could win an order for, reoccurring orders for, they needed to get this subcomponent at their loading dock in 30 days or less. Could it be done? That was the challenge given to one of these greenbelt candidates. Could the business satisfy these orders if we needed it in 30 days or less? And here's how the greenbelt candidate proceeded to do the analysis. First drew it out like we did, then let's draw the spec at 30 days. So now the question is, how often are we going to get product in that red region of 30 days or less? Well, I can tell you already that if we were at 45 days or less, that would be 50% of the time. And we know from the empirical rule that this region right in here, so if that region is 34%, I know that the region below here, all of this, so it's going to be less than 26% of the time just from using the empirical rule. So even before we start working with z-scores, I know it's going to be less than 25%, but let's use z-scores to do the full analysis. So because this didn't land on the plus or minus 1, 2, or 3 standard deviation line, our point of inspection at 30 days, we're going to use z-scores. And we know the z-score formula is x minus mu all over sigma. And if that's a new formula for you, I encourage you to go to those background videos that cover z-scores in further detail. And we know that our point of inspection is the 30-day request, 30 days or less. Mu is 45, and sigma is 10. All of this information, 30, 45, and 10, comes straight from either the information we collected historically or a need that our customer or the organization has. And so let's just do some quick arithmetic here. So we know we've got a z-score now of negative 1.5. Now, that alone doesn't help us. We now need to use this negative 1.5 z-score value and compare it to a z-score table to get the actual percentage that's in this red region. So I'm going to pull up a z-score table. So I've got a z-score table right now that I pulled up from the workbook. We could pull these up off of the web. Any business stats textbook will have one. And it was included in the problem sets. But now with a z-score of negative 1.5, I then take a look at where that lands on the table. And negative 1.3, 1.4, 1.5, here it is. And I know that's a little hard to see, so I'll zoom in. All right, so now with it zoomed in, if I take a look, negative 1.5, that's 6.68%. All right, let's go back to the problem and resolve this thing. Okay, so here's what we've got after taking a look at a z-score of negative 1.5 in our z-score table. We find out that that's 6.68%, and that equates to the amount that's in this red region right here that I'm now, I guess, coloring in blue. But you get the idea. And so the question is, what percent of the time does the product get delivered in 30 days or less? That is that's going to be 6.68%. And now the follow-up question, would you risk it and spend the extra money on special shipping? This is more of an opinion question, but if you know that if you just leave it to the historical process performance that only 6.5, let's call it 7% of the time, we're going to get product in a time frame that's going to meet our customer needs. I'm not liking those odds at 7%. You know, if it was 80, it was 90%, yeah, I'd probably not make any changes and go and just deal with the special circumstances when it happened when it was late. But if it's happening almost all the time, I'm going to have to spend extra money for special shipping or something to speed up this process. And I would be asking the organization, did we consider that when we decided to work with this new client that requires it in 30 days or less? Did we increase the price or add a little bit to margin? Because if we didn't, we're probably going to lose our shirt. Only 6.5% of the time are we getting it in this time frame. Or we need to take a look at, is it appropriate anymore to have a supplier that is so far away from Acme Corp that it's always having to take 45 days? We may have to take a look at some supplier relationship issues. So there's question number 4. There's a follow-up on question number 6, and I'd like to take a look at that next. All right, let's take a look at question number 6 now, which is a continuation of 4 with the shipping problem that we just resolved. In question 6, we've got the mean is 45, standard deviation is 10, same as before. But now what we want to do is we want to take a look at what's the percent of time that it'll fall between 30 and 45 days. So let me draw that out. Okay, I've drawn out the text, and we're looking for this region in red right now. I could start all over calculating z-scores from the beginning, but we have enough information from question number 4 to solve this, I think, because we already know the region below 30 days. The region below 30 days, the region in yellow, that's 6.68%. We get that from our z-score calculations earlier. We also know that from 45 days or less, the region in green that I'm about to color in, well, that's 50%. You know, that's right at the mean, so we know 50% is below that. So we've got the green region, which is 50%, minus the yellow region, which is 6.68%. My arithmetic gives me 43.32% for this region in red. So now you've got to make some business decisions. If now the client is okay with it arriving between 30 and 40, or if the organization is fine with the subcomponents arriving between 30 and 45 days, um, are you okay with not quite half the time getting those subcomponents in that time frame? If you're not, you're either going to need to take a look at different suppliers, or working with that supplier on expediting, or working with the client on maybe changing terms of the contract or increasing margins. I don't like the fact, though, that less than half the time we're going to be able to get the subcomponents in a timely manner needed to satisfy our customer needs. Both of these solved with z-scores, and pretty easily, pretty quickly, something that you can use to help the business make better decisions. Let's now take a look at question number 7, which was less supply chain, a little bit more service transactional oriented. All right, question number 7 is more of a service-related question. We've got restaurant service times are normally distributed with the average of 10 minutes and the standard deviation equal to 3. Again, this could have been data that we captured from historical observation. And what we find is that service encounters or what we're being asked is, what's the chance of a service encounter taking longer than 15 minutes? Let's draw this information out. All right, so now with this drawn out, what we're looking for is the region above 15 minutes. So I'll color in this. This is what we're looking for. If it landed right on 16, I could use empirical rule. If it landed on 13, I could use empirical rule, but because it's in between, I'm going to use z-scores. All right, there's our z-score formula. Let's plug in the numbers and see what we get. By plugging in those values and doing a little bit of arithmetic, I get a z-score equal to 1.66. But remember, our z-scores that we've been working with in the z-score table that was provided in the workbook and that we've been using is for z looks at values below. So these regions in green. So when we do look up the z-score value for 1.66, we're going to have to say that's the green region, and 100 minus the green region is going to be equal to our solution. So just a little bit of foreshadowing then on how we'll get about solving this. Let's pull up a z-score table and take a look at what the value is for 1.66. Okay, so now I've got a z-scores table pulled up. Remember, for this table, we're looking at the regions below the line. So that'll give us the value for percentages for the green region, not for the red region. So let me change my pen color to green. So if I look for 1.66, there's 1.5, 1.6. Okay, so they don't have 1.66. They just have 1.6 and 1.7. So if I take a look at 1.6, that is 94.52%, and a z of 1.7. Z of 1.7 is 95.54%. So if we're looking for a z of 1.66, it's somewhere in between. I'm feeling pretty comfortable that if I say a z of 1.66, it's approximately equal to 95%. 95% is then this green region. So then 100 minus 95% is what the red region is that we're truly looking for. So this region is 5%. So now we know what the time is for service encounters that are less than 15 minutes. We also know the time for service encounters that are greater than 15 minutes. So I hope walking through some of these problems gave you a little bit of help and insight in using z-scores and z-score tables to help with making business decisions and how these concepts can be used in the world of process improvement by taking a look at a supply chain and a service-related problem.